answer for that one.
Okay. And I think the instructions was add like terms, multiply out parentheses first. That's all it says.
Yes, and that's exactly what we accomplished here. So
Okay.
look at letter D. If there's any questions on that, though, please let me know.
Okay.
But we'll just move on here. Let's get a little more space here. Okay, so this says 14 minus 6 times the quantity 3 minus 2x plus 5x minus 3. Couple things here is the 14 is really positive, even though it's not written, it is positive. And you want to treat that subtraction symbol as going with the 6. Okay, so this is minus 6. When you take the minus 6 into the parentheses, you're distributing the minus 6 to both terms. Now the minus 2x inside, the minus inside here really goes with the 2x. Okay, so in terms of what it looks like, it's minus 6 times 3 minus 6 times minus 2x.
6, 3. Okay.
And when you're simplifying something that's this complex, sometimes you just deal with the stuff that you're working on. You don't need to bring everything down yet. You can, but you know, maybe there's so much going on you don't want to do that. It's kind of up to you. When you do it the way I just presented, you always put a plus in between the multiplications. So minus 6 times 3 is minus 18. Minus 6 times minus 2x is 12x. And this is the time when you bring down the numbers. You bring down positive 14. You bring down the plus 5x. And you bring down the minus 3.
So the plus is after the 18 and between the 12x. The plus 5, sorry.
Yes. Like that plus in front of the 5. I mean, it goes with it. It goes with the 5x.
Oh, it's
The subtraction goes with the 3. It's really negative 3.
Okay.
You have to look that it goes to the right. It's like an adjective that describes it, so it needs to go with it. So now you're up to the step where you can actually combine like terms. So you got 14 and minus 3. Now, if you're not comfortable, you can group them, meaning you write them next to each other before you subtract. Or if you just know, okay, I know the answer is 11, you can write 11. Okay. And actually, I missed one. I'm sorry.
Yeah, I was going to say, why wouldn't we do the negative 18? Because that's also okay.
Yeah, I apologize. I was looking at something else. So this is, let me rewrite. It's 14 minus 18 minus 3. And perhaps this is uncomfortable. Last time, I believe we talked about changing the subtractions to adding a negative. Adding a negative. Does that look familiar to you?
No.
Okay, so let's not do that. Let's not do that. Let's do them one at a time.
Okay.
Okay, so 14 minus 18. Okay, so one's positive, one's negative. How do you determine whether it's positive or negative? Do you remember?
The larger number, sorry. So the 18.
Yes, we know the answer is negative, and then we take the larger number and subtract the smaller.
Yes.
So it becomes negative 4.
Okay, so remember that part.
We've dealt with 2 of the numbers, but not the last one. So now we got to bring it down. Minus 3.
Minus 3. So it's negative 1 again, or yeah.
They're both negative. So the answer is negative. That's for sure.
Right.
Okay. But since they're same sign, meaning they're both negative, you add the numbers together.
Add them. Okay, so negative 7.
Yes. All right.
It's like just remembering when you keep them positive or negative.
It's a lot there. Yeah. Math is full of things to remember. So next line here is our next thing to combine is the 12x, positive 12x, and the positive 5x. When they're both positive, usually that's the best case for most students. You just add the numbers together and keep the x's. So it's plus 17x.
And that's the answer.
Yes.
Well, Matthew, you make it look so easy.
Yeah, but how are you feeling? Are you feeling any better about this, or is there still
I'm doing okay. I think it's just like repetition. I just have to keep doing them, because I'm only working 2 to 3 problems, maybe 2 to 3 problems of each with you. So then there's like 5 to 6 in each section. So I struggle working out the rest, but I
Yes.
have to go through the struggle in order to learn. So
Right. So one suggestion might be to send me the more difficult ones in the group to work through, and then to let you try the easier ones on your own.
Okay.
That's sometimes more helpful than sending me the easy ones and the ones you do on your own, the more difficult ones. But the next problem I see is a 50 letter A. Does that sound right to you?
Yeah.
Okay, so we got 9x minus the quantity 5x minus 2. Now what's implied is that it's really -1 in front. It's really a -1. Like that's what you're going to distribute into both of these
Okay.
is -1. So you treat the subtraction sign with the -1 there, and you're going to take -1 and multiply it by 5x.
-1 times 5x.
And I'm highlighting it here because I really want you to see that like you take the operator with the number. Same thing over here. It's really -2. You really want to look at that as -2 there.
Okay.
So that -1 that you're distributing in, it's -1 times -2. And then if you do it the way I'm showing you, you can always put a plus there in the middle.
Okay. Yeah, I think this is easier to remember like this with the plus in the middle.
-1 times 5x is -5x. -1 times -2 is +2. +2 like that.
+2. Okay.
And then very important is not to forget to bring down the things you were not working with.
So the 9x.
Yeah.
Okay.
Now you might be wondering, well, what goes here? But we've already accounted for it right here. Okay, so
The negative.
so the negative is already part of the 5x. If you wanted to, you could put a plus here, but the point is that you've already handled the signs. When you've already handled the signs, it's always plus in between.
Okay.
Right. So you've got now to combine like terms. So what I see here is that the 9x goes with the -5x. Let's write those together. 9x minus 5x.
9x.
What does that reduce to?
5x. Let's see. So well, I thought we're using the positive since the positive is.
It is positive. So the answer, it is positive, but you're adding a negative. So these are equivalent. Like if you want me to, and I can bring that down. You can treat it as plus -5x.
So 14.
But one's positive, one's negative.
Oh, -14. Sorry.
Well, so when they're opposite in signs,
you subtract. Okay.
yeah, and it's positive because the 9 is positive. And it's the larger minus the smaller. So it's just 9 minus 5.
Okay. So just +4.
X, yeah.
Okay.
We can do a few quick review exercises here to just look at this again, but +2, there's nothing to combine with it. So that just comes down.
So 4x plus 2.
Yeah.
Okay.
So let me write down we got plenty of time here to do this. Just give me 2 minutes to try to get you to think through a few of these problems.
Yeah, I'm going to grab a pencil really quick. Sorry.
Okay.
Okay, I'm back.
Okay. So here are some problems that you might see. -7 plus 4. Okay, and they might have an X or not, doesn't really matter. But these are opposite in sign. Okay. One's negative, one's positive. So when they're opposite in sign, you have to first determine the sign.
The larger number.
Yeah. So is the result positive or negative in this case?
Negative.
Negative. And then the second thing you do is you take the larger and subtract the smaller without the signs. So you treat it as, and I think what I did last time is I said, look at this now as like a 7 and this as a 4. So it's 7 minus 4. And that becomes
a -3.
-3. Okay. So similarly, I could have you do something like 11x minus 16x. Okay, these are opposite in signs. The 11x is positive. We don't write that, but it's positive. And the 16x is negative.
Negative.
It's the same algorithm, the same recipe. You got to determine the sign. Is the result positive or negative?
It's negative.
Negative, yeah. And then you take the larger, which is the 16.
Minus 11x. Okay.
And that gives you minus 5x.
Mhm.
Gonna bring the x down. Okay, so that's the case when you do this when they're opposite in signs.
Okay.
And so
Determine the sign.
yeah. So I actually think this is something really small for you. Like once you get this down, you're going to have a lot more confidence going forward in the class, because probably you've been hung up on this for years and it's.
Yeah, I got an 80 on my first assignment. I mean, it wasn't terrible, but I struggled with it. But
Okay. All right, we'll see if that grade can get up here pretty quickly. Now, if they're same signs, okay, if they're same signs, you already know the sign. You already know the sign. Like you don't have to figure out the sign. The sign is the sign. I don't even know if that makes sense, but
it's whatever those two are.
right.
The same sign.
So if it's like -7 plus -3, we already know the answer is negative because that's what it is. And then you add the numbers together without the sign.
10.
Yeah, so just I'll do it in some colors here because I think that could be useful when you look at it later on. Again, you treat that as 7, you treat that as 3. 7 plus 3 is 10. So the answer is -10.
-10.
Now where you're probably running into issues, we'll look at this example, is what if it's -2 minus 6?
Well,
Do you believe, or not believe, do you see that this is same signs? Like you see that -2 minus 6 is same signs?
yes, I do.
Yes.
The
Okay.
-6 and a -2.
Because that's really critical here. If you don't see that, then it's hard to go forward. So the result is negative, and then you treat the numbers as if they're just positives now.
6 minus 2.
No, you're adding.
6 plus. Okay.
Yeah, you're always adding when they're same signs.
Like sign. Okay.
Yeah, like signs, like same signs, you always add.
Okay.
All right, and you got -8 there. Okay, because the next examples are ones you've known your whole life. Like what is 4 plus 3? Well, it's 7. They're same sign, you just add the numbers. Is that okay?
Yeah, no, you're fine.
Okay, so what I would recommend is like looking at this part of the video later, the notes later, and just trying those out or making some up on your own and
Okay.
seeing if they make any more sense to you. It's kind of thing, if you review for a few days, you'll get it down forever.
Yeah, it's just repetition. I mean, I feel like 5 problems is not enough for it to
No.
click for me. I have to do it
Yeah.
over.
And we don't do this very often in real life. We're not actually adding and subtracting like numbers like this very often. So it just happens in the classroom.
Great.
Okay, so this first thing on the outside here, this is letter B, is we're looking at this as -3. So the -3 is what you're distributing into both the 4 and the x. Okay, so what that looks like, and you've seen me do it a number of times now in parentheses, -3 times 4, -3 times x. And I can omit the plus symbol when it's positive. That's kind of standard convention. If you do it this way, you can always put a plus in the middle.
Okay.
So you'll hear me say always, and I'm very selective with that, but always is great because there's never any exceptions. You'll also hear me say this works sometimes, and that's when we've really got to pay attention to what the exceptions are. So this subtraction on the outside is really -6 is the way you want to look at it. On the inside, it's -3x. Okay, so that becomes -6 times +1, -6 times -3x. And then if you do it this way, you can always put a plus in between.
Okay.
Okay. So now when you're multiplying, There's the two cases. If a negative times a negative makes a positive, positive times a positive also makes a positive, negative times a positive, or positive times negative both become negative. Could you tell me what the next line looks like here when you multiply everything together?
Uh, let's see, where are we? So
Right over here on the left.
you would bring the 3 down, I think, but that's like after you multiply the stuff first, right?
You got to multiply these together. Yeah,
So
I'm asking. Yeah.
So -3 times 4.
Yes. What what does that? What is the result of that?
Well, it's a negative and a positive, so it's -12
Good.
plus, let's see, I don't know, the -3 with the 3x. Can we do that?
Yeah, it's negative 3x.
-3x.
Okay, and then you got -6 times +1.
Okay. -3x. And are we still bringing down the plus signs on the next line or no?
You
We
can.
are.
You can
Okay.
if you like. Sure.
Okay. Where are we? I'm sorry.
-6 times +1.
So we're at negative, I'm sorry, yeah, -6
Good. And then
plus,
last one here,
neg-
-6 times -3x.
it's -18x.
They're
Or
both
18,
yeah, they're both
18x.
negative, so it becomes positive.
18x. Okay.
Good. Okay, so now we're going to combine like terms, the -12 and the
And then
-6.
-6.
Okay, so we just talked about the four cases here. These are same sign. So that tells you the sign of the answer. It's negative.
-18.
Yes, beautiful. Okay, the next terms, -3x, +18x. These are opposite in sign. One's negative, one's positive.
Still negative.
The answer depends on which one is further from 0, which is the bigger one.
The 18.
Yeah, so
positive.
we know it's positive. You take the larger and subtract the smaller.
So 15x.
Yeah. Okay, so your final answer is -18 plus the 15x.
Okay. Okay.
Close here. You know, it's a little bit, a lot going on here.
It is a lot. It's so overwhelming.
Yeah, and so if you have time, it'd be great to redo these problems that we've worked on. That will certainly help
for sure.
here.
For sure.
But I know that's not always possible or practical. Okay, so we finally got some fractions, just to add another little wrinkle. It's like, finally barely got the thing down and now we're multiplying fractions, but it's the same approach. You take that fraction and you multiply both terms inside parentheses. Just like before. So it's 3/4 times 3. 3/4 times -2x. Like that. You can put a plus in the middle. And then you take the -1/2, and that you're similarly distributing to both terms inside there. So even though it's a fraction, you do the same process. Is there anything about that that you would like me to clarify?
No, I'll just follow along because this is like already overwhelming me.
Okay. Okay, you're doing great. You're doing great, but yeah, I understand it. It's not ideal. Now you can always write a number like this 3 as a fraction. Okay, and so what I mean by that is it's really 3/1.
Okay.
And then you have this 3/4 down here. So it's 3/4 times 3/1. You multiply the tops and then you multiply the bottoms. So that becomes 9/4. So if you notice, we're kind of like, it's kind of like a funnel. You're working on just one piece of it, and then we move to the next piece to work on.
Okay.
So similarly, the minus 2x is really minus 2x
Over
over
1.
1. And then you have this 3 over 4 here. So it's not 3 minus 2x, it's 3 times minus 2x. Okay, and that becomes minus 6x.
6x.
And then you multiply the bottoms and get 4.
Okay.
And that plus keeps coming down. So now we're up to this next term here, minus
negative,
1. Sorry.
Okay. No, I was just gonna say -1 over 2 and then 3 over 1.
3x over 1. Yeah.
3x over 1.
And you multiply the tops, -1 times 3x. So this maybe I haven't drawn it well, but the minus goes with the top. -1 times 3x is minus 3x. 2 times 1 is 2. Bring that plus down. Last one here, -1/2 times -4 divided by 1. -1 times -4 makes a positive. And then 2 times 1 is 2. You add those together.
Plus 4 over 2.
Is the multiplication step okay? Clear?
Yeah.
Okay. So now we're going to combine like terms. 9 over 4 plus 4 over 2. 9 over 4 plus 4 over 2. I can't remember. Are you allowed to use a calculator, or are you?
Yeah, we can use a calculator.
Okay. I mean, you could try putting this in a calculator. There is also the by hand way. I don't want to bore you with by hand if we don't need to. But if your calculator does not give you the fractional answer, that could be an issue as well. So what do you want to do here? Do you want to try it in your calculator? Do you want me to show you how to do it by hand? What would be best?
Well, I guess I'd like to see how it works out by hand if possible.
Okay. Yeah. So it doesn't take very much effort. You need to make a common denominator now, which will be 4. So that means you multiply the two numbers on the right by 2, and that gives you 8 over 4, and then 9 over 4, and you add them together. So the 9 over 4 just came down. The 4 over 2 is what you had to manipulate because you need the same bottoms. And so it becomes 17 over 4.
Okay.
If you're a social media person, there's a lot of videos on how to shortcut this, but this always works, what we just did.
I got an app also called Mathly. I think that kind of has helped with some of the problems when I get stuck.
Yes, lots of stuff out there. They unfortunately don't give good explanations, which
they don't.
But
I think that's why I got an 80, because I had to kind of look at that a few times, but I passed with a decent grade. I'm okay with that.
Okay, so we're gonna do the same thing now. We're gonna combine -4x. Sorry, we're gonna combine -6x over 4 and -3x over 2.
Stupid pencils. I'm sorry. I have these pencils that have like.
So this has the same problem. They have an unlike denominator, and you can't just add them as is.
Oh, there's -6x and the -3x, you mean?
Yeah, yes.
Okay.
The one's over 4 and one's over 2, and you can't just straight combine them. There's no way to do that. But you can make them a common denominator by multiplying the top and bottom by 2.
2.
-6x on the right here. Bring the -6x down here. Now, be very careful how you answer this, because they're both negative. They're both negative. So what does that tell you about the answer?
Oh my gosh, where are my notes? Well, they okay. Don't kill me.
That's okay.
The sign stays the same.
Right, because what I don't want you to say is the answer is 0, because it's not. So then you add the two top numbers together, 6x plus 6x.
So negative.
So it becomes negative 12x over 4.
12x over 4.
And you might think you're done, but you can actually take 12 and divide it by 4. 12 divided by 4 is 3x.
3.
And now you are officially done with this one.
17 over 4 minus. This one was way too long. This is way too much. This is like,
The fractions really add to the degree of difficulty.
my goodness. Okay, yeah, I'm gonna work on that last one on my own.
Okay, so
I didn't really understand this inequalities, intervals, line graph thing. I imagine.
okay. Yeah, so let me grab, so 14a says the inequality part is -4 less than x less than -1. Okay, so what is this? And let me go out of order here. So imagine a number line, and here's 0. Actually, let me put 0 in a different spot. Let's say that's 0. So that's -1, -2, -3, and -4. Okay. Now I have to go to in words to describe this. In words, it says all the numbers between -4 and -1 exclusive. Okay, so it's everything in between -4 and -1, but it does not include the endpoints.
Okay, so like -3 and -2.
But it also includes like -3.5
Yeah.
or -1.5 or -2.3758 and so on. It's everything in between there. So in terms of the line graph, you have to know a few things to be able to do this. So first is that this symbol and this symbol, they go with a not filled in dot on the number line. Did you see that in your notes or in class?
No, I'm not gonna lie, I'm sorry.
Okay, so at -4, you're going to put a not filled in dot there.
Okay,
And similarly at -1, you're going to put a not filled in dot. And it covers that point to indicate that it's on that point. And then you have to shade. So you shade everything in between those two places.
okay.
So the shading tells you, like, if I just gave you the graph, you're supposed to say, oh, it's all the numbers between -4 and -1, but it does not include -4 and it does not include -1, which is what the inequality says. They all say the same thing. It's just that they're all, there's 4 different ways to say the same thing.
Okay. Oh, I see. So like on line B, they want us to write the inequality versus.
Yeah, and I'm sort of doing the different order. I'll get to the last one here, which is the interval. So I'm gonna do this right here. The left number goes with a parentheses, an open parentheses, and the right number goes with a closed parentheses. Okay, so your interval, and I'll clarify all this in a moment, but the interval is parentheses -4, and the reason it's -4, it's because of this number on the left, comma -1. The reason that is because the number on the right, close parentheses.
Okay.
So for part A, I know I've just beaten around the bush and all this, but this is the second box. This is the third box. And then this is the fourth box.
She actually said we could skip the word box. I don't know if you saw the scribbles on there.
Oh, I didn't. Okay, now I do. Now I see it. All
Yeah,
right.
she just wants us to focus on the other 3, the inequality, interval, and line graph.
Yeah. Okay. So there's actually a better way to present this, but you're not seeing it. Like there's kind of a nice little learning staircase you can go up, but you're not getting that here. So I'll just go to B, if that's okay. Or do you want me to go to like D because it's more like A?
No, that's fine. You could probably just do the other one that I haven't done yet, and I can work on the rest on my own since I kind of need to learn it. I just like a few examples. And
Well, let's do another one of these betweens, okay? Because I think that could be. So the easiest place to start is like, let's say I say the number is between 3 and 7. This is just an example here. X is between 3 and 7. It's all the numbers between 3 and 7, but it does not include 3 and 7. So the easiest way to go from here is the interval. Okay, it's 3 to 7. And because these are less than and greater than, instead of less than or equal to or greater than or equal to, you use parentheses with these. Okay. Right. And so on a line graph, it's repetition here. You're gonna see 3, 4, 5, 6, 7. And because it's a parentheses, because it's a less than and a greater than, use an open dot on both of those points.
Okay.
And then you shade everything in between.
Okay.
Now, a couple more things on the right here. It's a filled in dot. So let me move that down. And then you'll end up using brackets for these other ones. All right, so let's look at I'm gonna do B, but I'm gonna give you the interval first. That's okay. 14B. I'm sorry, I'm gonna give you the inequality first. So here's the inequality. 3 less than or equal to X less than or equal to 8. So that's the inequality for B. And you'll see why in a moment why I'm doing this. The interval from the inequality, you take the two numbers and you put a comma between them. Okay, and then you have to go over back to this chart on the right here where you realize, oh, if it's a less than or equal to or greater than or equal to, I use a bracket.
So the bracket has to have the underline.
Yes,
thing.
yes,
Okay.
exactly.
Okay.
Exactly. And then when you go to a number line, let's just say that's 3, 4, 5, 6, 7, 8. This time, if you go to your chart over here, you're like, oh, it goes with a filled in dot. So at 3, you put a filled in dot. At 8, you put in a filled in dot. Because it's a bracket, because it's a less than or equal to, that's why you do that. And then you shade everything in between.
Okay. It's easy enough. It's not too bad.
Okay, so these are the between inequalities. Okay, so there's also one-sided inequalities, and that's what letter D is.
Okay.
So this says X greater than -3. In words, this means all the numbers bigger but not equal to -3. So everything bigger than -3. Okay, which it's -2, -1, -0, and so on, but it goes forever to the right. So this time it's a little bit harder to figure out the inequality because in the previous ones, or the interval, because in the previous ones you had two numbers.
Right.
Here you only have one number. Okay. So here are the two options. The two options are it's either -3 to infinity or it's -infinity to -3. Okay. And I'm presenting them to you as options because I want you to decide which one is correct. The first one says it can be any number up to positive infinity. So as large as you can think of. The one on the bottom here says it's any number towards negative infinity, kind of the smallest numbers you can think of. Do either of those map to this X greater than -3 to you?
The bottom one.
Okay, so on the number line here, try this different way here. On the number line here, if this is -3, here's positive infinity and here's negative infinity. So this greater than means all the numbers to the right of -3. Probably still isn't making any sense, is it?
No, I'm confused.
Yeah. So we should have done this first. Okay.
Okay.
So we should have built the number line first. So if the number line went forever, it goes to negative infinity on the left. And if it goes forever on the right, it's positive infinity on the right. You just think of it going out as far as it can go forever and
Right.
ever and ever. -3 is right in the middle. This is saying all the numbers bigger than, greater than, greater than. So greater than always means to the right.
So from -3 to infinity was the first option.
Yes, yes. And in terms of how you might do that, open circle here. And this is incorrect, but this is how I think we should think about it. Open circle here. Okay, and then you're shading everything in between. So now we have those two numbers. We have the -3 and the infinity. We've got the -3 and the infinity. And so when we go back to our chart up here, we realize that if it's an open circle, we use parentheses. So this is kind of a big takeaway from 14. Like this is the thing you gotta know out of doing problem 14. We'll do another one, but we'll let me know when you get all this down. Or
I got it.
okay, so let's do another one here. Let's do another example here. Let's say it's x less than or equal to 6. Okay, so sometimes it's better to go straight to the number line. Okay, so here's 6. On the right's positive infinity, on the left is negative infinity. Less than or equal to or less than is always shading to the left.
Right.
To the left. And if you're ever unsure, you can always pick a number. You can say, like, you can ask yourself, well, is 5 less than or equal to 6? Is that true? Is 5 less than 6? And you say, yeah, that's true. And 5 is over here to the left. And that tells you which side to shade. Okay, it's good if you know that the less than or equal to means to the left, but you can always test a point to decide that.
It helps to draw out that graph, you're right.
Yes, yes. And normally I would do this first, but this was presented really weird, so that's why we didn't do that. But a less than or equal to, if you go back to our chart, less than or equal to corresponds to the dot, the filled in dot. So you're going to do that. You're going to put a filled in dot here. Okay. And you're going to go to the left. Okay. Now, here's one of those exceptions in math. Infinities, whether they're positive or negative, they always go with the parentheses.
Okay.
And the reason is, if you care to know, is that infinity is like a destination. You never actually get there. So that's why it's a dot that's not filled in.
Okay.
So in terms of your interval now, because you have the line graph, you know that it's -infinity and 6 there. Because the dot is filled in, it's a bracket on the 6 side. But as I just mentioned, negative infinity, positive infinity, they always go with
Parentheses.
Parentheses, yes.
Okay. Matthew, it's all weird. You were mentioning that this problem was written weird. They all are, just so you know.
Yeah, this one is extra awful for a first time learner, for sure.
My nephew, he's an engineer for Lockheed Martin in Fort Worth, so he loves this stuff. He's like, really? They're struggling with that?
Well, math is easy to a lot of people, and for everyone else, it's a real challenge.
Yeah, but I really appreciate your time. I mean,
Yeah.
it definitely
Yeah.
helps.
We've got some more time here. So what else can we do here? Do you want me to continue going through 14? Are there some other problems? We got at least 7. We got 7 more minutes.
7 minutes. Is there a way you can glance through some of the homework that I sent you? I think I emailed you some of it, and just like point out the first one you see wrong and what I did with it.
Okay. Do you want me to like snip it in and look at it, or just look at it on my email side?
Yeah, just look at it on your email side and just write out the problem.
If I see something here. Okay.
I'm sure.
Yeah, that looks good. All right, so could you give me more information on how it was graded? Did they pick a particular problem and grade it, or did they look at all the problems and grade it?
So that's like one of our complaints right now. This school is really new to Tucson, and they're doing that teaching method that I was telling you, where they have you struggle with all the assignments and then you turn in your homework and then they correct it. Well, she gave me a grade, but she did not point out anything I got wrong. So the dean's sort of talking to her about how she has to grade her homework. It's just like the craziest school I've ever gone to.
That's
You get no
different.
feedback. How are you supposed to learn if you don't get feedback?
Yeah, I don't, you won't like my answer to that because I don't like the way they presented that to you. But 30A, I just noticed here on the first page, is this -8 minus a -9, or is it
Yeah,
minus
it's
eight?
minus.
So
minus
it's
it.
-8 minus a -9 like that.
Yes.
Okay, so this becomes -8 plus +9. Plus +9.
Okay.
And that's because the two negatives make a positive or a pair of positives. And you can write
See,
this.
there we go again, getting the wrong answer because of those negatives and positives.
Yeah, it's okay. We got timer. So C's also got an issue. And you probably know how to answer it now. They're both negative. So the answer is negative, but then you add the numbers together to make 13.
Okay. Okay. I have to do them over and over in order for it to stick. This is crazy.
Yeah.
That's like my challenge is like figuring out the sign. But I think now that we've covered it over and over today, like you go with the larger and then, okay.
It takes extra time, but if you look back, you would notice like this one's also got this kind of see, this is correct right here, this line. -2 minus a -5, it becomes -2 plus +5, and that's correct. But that means that the answer is positive because 5 is further from 0. 5 minus 2 is 3, +3.
+3. I got -3.
Yeah.
Okay. Well, you probably brought my 60 up to 70.
Yeah. So this next one is 34B. Do you want to see the mistakes or do you just want me to work through the changes?
Well, we don't have a lot of time.
Well, we're
So
moving pretty quickly here. So
yeah.
5 minus 7. So this is correct. Like what you have is 5 plus -7 is great. That's totally correct. But now you got to remember what we talked about today. It's negative because the -7 is larger, further from 0, and then you take 7 and subtract 5.
Yeah. Oh, -2.
Yes. So these are good ones to keep working if you got the time for that.
Okay.
Okay, 28. Good. Good. I'm up to 30C on another page, I think. Here.
Okay. I was really confused with the 2.36A. I don't know if we have time for that, but I thought didn't we do that one together?
Yes.
Okay.
Yeah, we can look at that again.
No, it's okay.
Okay. Looks good. Okay. Squared over 3. Okay, got a little small error here in 2.326B.
2.326B. Okay.
Probably, I know it applies to the next one. Yeah. So we'll look at this real quick.
9N.
Okay, so yeah, this is the thing you emailed me about, and your answer was so perfect. Like a lot of times students send me an answer and that's just like it's completely wrong. You said it. This means 3n times 3n times 3n. Well, wait a second. Is it to a power of 3? Is this an exponent of 3? Let me make sure that's correct.
Oh, that's a good question. Because that's where I was getting confused.
I think it is. So I think it is because the letter A is a power. So I'm going to just go with that for this one.
Okay.
So this would be 3 times 3 times 3 is 27. N times n times n is n cubed. And then on the bottom, excuse me, it's 4 times 4 times 4, which is 64. This one, a letter C, minus 4x times minus 4x. Minus 4 times minus 4 times minus 4 is minus 64. X times x times x is x cubed. And then on the bottom here, it's the same thing. It's 5 times 5 times 5, which is 125.
Okay, I was way off.
You did A right. You did A completely right. You wrote it out right. For some reason, I bet there's just a transcription error from, I think you thought this was multiplying by 3 and not power of 3.
Yeah, and that's actually what I got wrong on a couple of them. The exponents, and I think I brought that up to your attention last time. It's like you multiply it by itself that many times and not by the actual exponent number.
Yes, yes. You
Okay.
stated really well.
I just have to remember those rules, like the same with positive and negative. That's like what's killing me right now.
Yes.
Okay,